Okay, hello everybody. Welcome to the 8th session of our Emerging Trends in Translation Quality class, Applied XLIFF. As I said before in class, this is where everything really comes together. All of the things that we've learned so far are very important, but if you can't apply them, then they're not of much use beyond just academic speculation. So in this class, we're going to show how to apply all of the concepts that we've learned so far to real use cases. These slides will be cover the concepts for the 8th session, which is not XLIFF modules, which is Applied XLIFF. And this is an online session. Making repairs as I go. This week we will be going over translating XLIFF, translating DITA, translating websites, translating Office documents, and translating graphics. I made the decision to not include translating software. As I began to prepare for this class, it dawned on me that that's really more of an advanced topic. So I'm glad that you were able to do your reading, and hopefully it all made sense to you. I'll be happy to answer any questions on translating software. But let's leave that out for the purpose of this class. So next week we will have an in-class session. Please come prepared with your questions on whatever concepts or tools you might need help with. Okay, so I've been kind of telling this story as we learn the different aspects of emerging trends in translation, kind of telling the story about what's the problem that we're trying to solve and why do we have, what are the solutions and why are they good solutions. So challenge 1. Do we send native source files directly to the translator or the localization service provider? The answer is only if you want it to cost top dollar, take a long time, and have errors. Converting to XLIFF is the solution to this challenge. And I think we're all, I've made this point quite a bit. Challenge 2. This thing I'm sending contains several segments that I've already translated in the past. Isn't there a way to leverage the already translated segments? Yes. As long as you or your localization service provider have been saving your translation pairs in the form of TMX files. But wait, can't I just store them in a spreadsheet? The answer is using an open standard lets you transfer the TM from the vendor from vendor to vendor and is directly accessible to the computer-aided translation tools. Okay, challenge 3. In my industry or my company, there are a lot of terms that could be ambiguous to translators who are not necessarily experts in our field. Also, we want to make certain that the terms are always translated correctly, consistent with my company's style guide. Can I send a glossary of terms to the translator to keep all of this straight? Answer. Store your glossary in TBX files. The tools can read these directly. TBX defines standardized ways to store, use metadata about terms. And again, since it's an open standard, you can pass it from vendor to vendor and they will understand it. Challenge 3. My XLIFF segment granularity varies and my TMX files and TBX files are not leveraging things I know are captured. It seems my XLIFF is sometimes segmented at the phrase, sometimes segmented at the sentence, and sometimes segmented at the paragraph levels. Is there a way that I can tell my localization service provider how to segment consistently in a way that best works for our business? Answer, yes. Use SRX. It's the open standard and it's supported by the tools and it works. Challenge 5. I struggle to convey best practices to my content providers in terms of preparing the source content in ways that it will be optimal for translation and conversion to XLIFF. I wish there was a way I could add processing for localization and translation directly into my docbook, DITA, SVG, HTML, etc. files. Answer, you can. It's called ITS, International Tag Set. You can put a ton of great translation aids right into your source XML with tools. Best of all, it's all turnkey with HTML5. Okay, challenge 6. I'm at odds with my localization service provider as to how to measure the translation efforts and how much I should pay. Going by word count for some of it, but many languages like Japanese and Chinese and others, there's no concept as a word. What metric can I use cross paradigm? Answer, use GMX. It's all been solved in a way that's unambiguous and traceable to an open standard. So, challenge 7, and that's what this is what we're talking about in this class. Okay, now I understand the best practices and which open standards I should use for which phase of my translation localization workflow. But do different formats require different approaches or have their own best practices? Answer, yes. You can apply most of the best practices you've learned so far to most formats and workflows. Now it's time to look at applied XLIFF. Okay, so the workflows that we're going to be looking at are translating XML, translating DITA, translating websites, translating open documents, and translating Office documents, and translating graphics. So starting with XML, let's look at the basics. The best practice for translating XML is to use the extract and merge method to transform the XML to XLIFF and do an XLIFF round trip, which we've talked about in earlier classes. XML can come in generic formats, or XML can come in specific vocabularies like XHTML, DITA, DocBook, or others. So starting off with generic XML, generic XML in this context means XML that does not have a specific transformation filter. We often call these XML transformations that need to have a vanilla transformation. Translating the generic XML goes sort of like this. The XML documents may contain translatable text in a lot of different places. The most obvious place is in PC data, plain text, inside an element. But it could also be in attribute values, in CData section, content that processors interpret as character data, not markup. Note that translating translatable text in CData is not a best practice, and it can also be in comments. So filtering XML to XLIFF works like this. There are two kinds of filters for converting XML files to XLIFF. The generic filters, they extract PC data from all of the XML elements, and I'll demonstrate that in the next several slides. And then there are vocabulary-aware filters that selectively extract translatable content depending on where the translatable content resides. And the demonstration for that is the translating DITA section, which I'm actually not going to do a demonstration of that today. I'm just going to make reference to the earlier video that I prepared for that. So to do a generic XLIFF filter, the example that I will use is the utility that I wrote. It's at that URL on the xmarker.com site. So you go there, you download the latest XLIFF roundtrip tool, unzip the files, you change directory to where the jar file is. You type java -jar and then that jar file name there. Then you choose the XML file to transform to XLIFF. You choose your file, and this is what the file looks like in its generic form. And then after you do the transformation, you see that the XLIFF actually looks familiar. You translate it to your target language. In this case, I'm showing Z-ish. And then you use the graphical, by the way, GUI stands for Graphical User Interface. You use the GUI to navigate to the XLIFF file that you just translated, and you convert it back into its original file format. So let's take a look at that. I'm going to demonstrate that. So I'm going to go into my XT directory, which I have somewhere. Bear with me for one moment. Okay, it's on my other screen. So we've been using this XT directory all along in class. So I'm going to go into my, so at this point I've already downloaded the utility and I've unzipped it in a place that I'm familiar with, and it has the various different versions that I can do. There's either a command line version or a GUI version. I'm going to demonstrate the GUI version. So I have to change directories. I'm going to open my command line, and I'm going to copy the path, and I'm going to change directories to that path. Okay, and then I'm going to see what's there, and sure enough my files are there. So my instructions say to, in fact I'm just going to see how good my instructions were by going back to them, copying them, and pasting them into the command tool. Okay, so it says it can't find it, so there was something wrong with, I must have done a typo, so I'll have to fix the slide. So I'll do it the old-fashioned way. I'll do a dir, and I'll see that the file that I want to access is in fact there. So I'll say java space minus jar space XRT4 X2 V01.jar. Hopefully this will work. Hopefully I typed it all correctly. Okay, so it gives me my copyright notice here. And then here's the graphical user interface. Not quite as fancy as some of the others that I've shown you before, but that's okay. I think you get the picture. So it says to click this button. Then I'm going to go to my desktop, and I'm going to go to my ET directory, and I'm going to go to my the actual samples that come with the software. And here I have, I'll show you this this actual sample here. Oops, that's not it. So if I go into my samples directory, I see that it's just a garden variety XML file. It's got some things in here. So I'm going to pick that file and transform it. So now if I look into that same directory, I see that it just made an XLIFF file. And sure enough, it's got all of my strings in there. So I'm going to do a quick and dirty pseudo translation into some language. So I'm going to find that, and I'm going to replace it with this, and I'm just going to write, what language should I translate it into today? Let's translate it into W-ish, www dash. Okay, so I'm going to replace all of those. Now I have a bilingual file with English and W-ish. I'll save that. And then I'm going to go into my choose XLIFF file to transform back to XML. And I see that I have that file. I'm going to transform it. And now I see that in that directory it created a back file. So now I'm going to look at it. And sure enough, it's the same format, but now it's in W-ish. So a familiar kind of a exercise that you've seen before. Point being that this is a generic filter that really doesn't do a lot, and it will work on any XML file. Okay, so this is what we did. Now let's talk about translating DITA. This is the next thing that we had in our applied XLIFF syllabus for today. So DITA is a Darwin information typing architecture, and its open standard is there at that URL. DITA is an XML vocabulary for topic-based authoring, archiving, and publishing. A DITA project consists of several topics and maps. So I'm going to give a little overview of what DITA is so that you get an understanding for the challenges with translating DITA, and then why the prescribed best practice is a best practice. Okay, so DITA Topics. The DITA topic is a basic unit of DITA content. The topic's scope is a single subject. The topic is short enough to be specific to a single subject or to answer a single question, but long enough to make sense on its own and to be authored as a standalone unit. DITA Maps are the mechanisms in DITA that enable topics to be organized for creating outputs or archives. Maps enable order and hierarchy of a set of topics. Maps come in two formats, either a DITA map or a book map. And the way it works is something like this. So you see I have some the things that are not polygon or whatever shape that is, but the things that are round cornered rectangles. We have a data sheet, master map, a user manual, master map, an instrument, online help, master map, and then we have a bunch of topics. In the real world there would be thousands or millions of topics, but for this diagram we see that the DITA map is making use of everything that's pointed to in blue, and the user manual is everything pointed to in red. And notice that some of these topics are used by several different maps, and then the online help is pointed to by the green lines. Okay, so that's just to show you that you've got a lot of different maps and a lot of different topics. These are all standalone files. So translating these can be difficult, or translating these can be easy, and that's because of the paradox. DITA's strength is its ability to harness many topics for a variety of outputs, and DITA's difficulty for the localization service provider is the many files. So the strategy is that we take advantage of DITA's map file in order to manage the many topics and the many topic files. We create an XSLT to read the map file and then convert each of these referenced files into a single XLIFF file. So this is the little cartoon that I kind of used to illustrate that. The person on the left is the one who is really excited about switching to DITA for a lot of good reasons, and the person on the right is the boss who is rather indifferent about it. Hey boss, let's switch to DITA. It's a component content management system. It's a great idea, huh? And the boss is rather unimpressed. Whatever. It's nimble. Ho hum, says the boss. No more document-centric constraint. Document what? Boss scratches his head, doesn't get it, gets bored. Supported by tools and best practices. Boss is already off doing something else because he's not following the conversation. We have more precise information for our customers, and boss finally goes down to brass tacks and says, show me the money. And the advocate says, we can save boatloads of money and time on translation. And the boss is all excited about that and says, let's get a box of DITA right away and get started. 9 months later, when they do the calculation, the translation savings are just not there, and everybody wonders what's going on. So the problem is that DITA files can be tedious to process one by one. DITA projects consist of hundreds, thousands, or millions of topics. A localization service provider can process DITA topics, but it's not their core competency. They rightfully will charge extra for the overhead and the expertise. So one of the ways around that is to use one of these XML language specific filters. In this case, we'll talk about the DITA XLIFF roundtrip tool. This is the one that I developed. You can look at the tutorial, the actual tutorial on how to do this at the URL referenced in your slides. Okay, so first thing you have to do is become familiar with the DITA Open Toolkit. The DITA Open Toolkit transfers DITA XML source content into deliverable formats like PDF or HTML or help systems, or in our case, into XLIFF. Nearly every DITA tool has a version of the DITA Open Toolkit integrated into its framework. The DITA Open Toolkit is located at that URL shown on the screen. The standalone DITA Open Toolkit is run at command line. Okay, so you would download and extract the DITA Open Toolkit and install it. And then you would need to download the DITA XLIFF roundtrip plugin that I created and I put out there on SourceForge at that URL there. You would then install the XLIFF and the ditafromxliff modules into the plugins directory. And then along with the software comes a sample project that I included. Surprise, surprise, it's about my guitars. So you could go observe it there and you would see that it consists of a map, some SVG files for the graphics, and then several topics. So you launch the DITA Open Toolkit command line. This is a DITA specific Open Toolkit command line. That's covered in the separate video, how to do that. You would change directory to the XLIFF directory. You would type this ant -f build _ DITA to XLIFF.xml. That's a build file that tells the plugin how to convert all of those topics referenced in that map to a single XLIFF file. It creates the XLIFF file. So then you would translate the XLIFF file, and in this case I got really lazy in my pseudo translation and just wrote prepended each segment with fake translate dash, and then did that throughout the whole XLIFF file. So then you would cd to the ditafromxliff directory, and you would place the translated XLIFF into the prescribed directory there under the prescribed name. You would type the ant file then that tells the Open Toolkit how to transform the XLIFF file back into all of the maps, images, and topics that make up the original DITA project. You would change directory into that root directory, and you could observe the translation worked. You see in this case, for each of those hundreds, thousands, millions of topics, I would have translated DITA Topics. Okay. So that's the way the first two bullets in our applied XLIFF work. The next thing we're going to talk about is translating websites. This is very obviously very common and a very big problem. And to tell you the truth, the industry hasn't really caught up with best practices yet. There are a lot of people struggling with how to translate their websites. That's why if you go to a translated website, you'll see that very often part of it is in English, a lot of it is out of date, the translations tend to be bad, in the wrong place, but there is hope. Translating websites has been a unique challenge. Unlike most content types, websites do not lend themselves to a simple file exchange with your translator. Therefore, you have two choices. You can allow the translator access to your site and have them translate on your server, which is almost never a good idea. Being non-web developers, translators can do harm to the website. Or the other idea is that you can export the files into an intermediary file format, have the files translated, and then import the files back into your website. This is the best practice. The key to create a good workflow is to include XLIFF as the file interchange format. A lot of companies just aren't doing it this way, and they're paying the price for it. Okay, so why is letting translators translate on the server a bad idea? I'll show you a use case with a popular web content management system called Drupal of how they prescribe, how Drupal.org in Drupal core prescribes you should do this. So you can look this up yourself at the Drupal.org website under Content Translation Core Module. Basically what they tell you to do is have the translator log into your Drupal content management system as the manager of the web team at my work. That just the idea of that makes me cringe. But anyway, that's what they say to do, so we're letting the translator log in. They click the Translate tab on the node they want to translate. They pick the language they want to translate into. So they have this node, and they see an interface kind of like this. First thing they do is they translate the subtitle. Okay, so far so good. And then they translate the detail title. That's good. They don't know what all of these things in the legacy channel code field are, so hopefully they'll just leave those alone. But then they see something that looks kind of familiar. Unique name. They must want it to be in German, so I will translate this unique name because it is it looks like a translatable word. So they translate it, and boom, they just blew up every node of this content type. So they broke the website by inadvertently translating something that shouldn't be translated. How do I know this? I'd rather not say. Oh, and they accidentally translated German into the Japanese page. Whoops. So that's why you don't want people who are not web developers or who are not trained on web content management systems to fool around with the words that are actually on the website. So let's show you a better use case. Why is leveraging XLIFF for translating CMS a good idea? And then the following use case will be translating again in Drupal, but using the Drupal XLIFF module that I created along with Gabor Hachi. Translating Drupal with XLIFF, the URL for this module in Drupal is right there. So the fundamental difference that this tool brings is that all Drupal steps are done by a Drupal administrator. The translator does all of his or her work using their familiar computer-aided translation tools. So the Drupal administrator logs in. The Drupal administrator picks the XLIFF module. They select the node type that they want to translate. In this case, we're selecting bit error rate tester, which was the same one that the bad translation or the bad way blew up. We export the nodes to XLIFF. We save the XLIFF file locally. Some post-processing is usually needed. In this case, we're going to prevent that problem that blew up the database by doing processing that protects this non-translatable field by putting the state equals final into the XLIFF. That locks it out of the computer-aided translation tools. You would have to do it rather tedious or an overdrive that would be in order to make that happen, which the translators hopefully won't do. So then, following the best practice here, the localization service provider is only doing the steps there that are in the yellow part of the diagram. They're going to open the XLIFF tool with their XLIFF file with their cat tools. They'll leverage translation memory. They'll translate with their cat tools, and then they'll give the translated XLIFF back to the content provider. The content provider will then do the rest. So they're leveraging the TM, they're translating it. So now we see that what we do want to have translated is translated, and what we don't want to have translated is protected and not translated. They send it back to the content owner. They import the XLIFF via the XLIFF module, and we have a translated website. Very nice. Okay, so the next topic is translating Office documents. By Office documents, I mean word processor documents, spreadsheets, presentations, things like this that are in the Office suite. Translating Office documents, there are really 4 ways to do this. You could send the file in its native format to the translator. You could transform the OpenOffice XML in the case of Microsoft, or Open Document XML in the case of OpenOffice, to XLIFF and do an XLIFF round trip. You could save the files as RTF, transform the RTF to XLIFF and do the round trip, or you could save the files as HTML and transform the HTML to XLIFF and do a round trip. So sending the files in native format, there are pros and cons. On the plus side, Microsoft Office formats are well known and not difficult to process. Most translators have the popular Office programs, so there's really not much expense in buying expensive software. On the negative side, it's still difficult to leverage translation memory files right out of Office files. It relies on de facto standards. That would be an agreement saying, please translate everything except for what I've bolded. Those are terms. Look those up on a spreadsheet or whatever. So it's kind of still an error-prone de facto process. And the translators are not using cat tools. So there's going to be some overhead there. The next option is to transform the Office files to XML and do an XLIFF round trip. The pros, Open XML, Office XML is documented and predictable. XML XLIFF round trip filters are available and reliable. For example, the XLIFF round trip tool that I showed you in the first demonstration would work just fine once the Office XML is extracted from the word processor file. On the negative side, extracting Office XML is not turnkey. It can be error-prone. You actually have to change the file name, unzip it, know which file to dig out of there, and then all of that can be rather difficult. And then the other con is that Office XML has a somewhat unorthodox architecture that's not always easy to be accommodated by filters. And in your reading, you saw some examples of that. So the next option is to transform to RTF and then do the XLIFF round trip. The pros, Office documents are easily saved as RTF. RTF format is documented and has been around for a long time. On the negative side, RTF from saved Office applications is sometimes unclean and needs to be repaired. RTF is not XML, therefore filters can be difficult to write and maintain. Then the last option is to transform to HTML and do the XLIFF round trip. I personally like HTML. I like that most tools, almost all tools, can export and import HTML. They do a relatively good job, so it's not a terrible option. The pros are that Office documents are easily saved as HTML. HTML round-trip XLIFF filters are simple and reliable. On the negative side, HTML saved from Office applications is often malformed and needs to be repaired. HTML imports back to Office file formats are sometimes inaccurate due to file element infidelity. You know, you can add things or remove things, and then that might produce unexpected results when you do the import back into the Office format. Okay, so I guess the moral of the story there is pick your favorite best practice. I would say of all of those, probably transforming to Office XML and doing the round trip is probably the closest thing we have to a best practice, but the other three are not terrible either. Okay, so translating graphics. Translating the text and graphics has been one of the most difficult parts of the translation workflow for a long, long time. People have just been pulling their hair out about this. Technical publishers and localization service providers can translate the text and graphics, but it's expensive and error-prone, historically. There are traditional methods versus what's emerging as the new best practice. So that means there are three different ways that I know of, that I've experienced. Traditional method one is to manually extract the text from the graphic, paste it into a spreadsheet, translate the spreadsheet, and then manually copy and paste the translations back into the graphic file. Traditional method number two is to send the graphics to the translator in the native format. You know, send a Photoshop file to the translator or an Illustrator file, for example, and let them do the translation. And then the third method, which is the best practice, is to use SVG scalable vector graphics for your graphics and then translate them via the XLIFF round trip. That's because SVG graphics render perfectly beautifully, but they are XML. Therefore, they're easy to process with XLIFF. So let's look at all three of those options. Traditional method number one, you manually extract the strings from each graphic. You provide the text strings to the translator in a word processor or a spreadsheet file. The translator translates the text strings, and the publisher pastes the translated strings back into the graphic file. So it kind of works like this. I've got all of these graphics. I copy and paste them in the left-hand column there. I have my English. I send that spreadsheet to the localization service provider. Hopefully they do a good job in translating the strings into the target language. So then we have this spreadsheet, and so then I copy and paste each of the translations into the place where they go into the proprietary graphics format, and hopefully I get everything right. The drawbacks of this method are that the method adds a lot of overhead for the project manager, requires extensive involvement from the translator, graphic artist, and technical writer, and can be error-prone. So let's look at a mishap. So I start off with my graphic, which is in English. I copy and paste it into the spreadsheet. They translate it into Japanese. I want to copy and paste it like this, but the operator misses that last character there, or excuse me, the middle character, and the graphic is incorrectly translated. Traditional method number two, send the graphic file to the translator in its native format. The drawbacks, we've talked about these before. It's difficult to leverage translation memory. The translator must purchase expensive software and learn how to use it, and they will pass this overhead expense to you, and it's error prone. So the solution is to use XLIFF and SVG. So why SVG? Well, SVG is an XML language for describing two-dimensional graphics and graphical applications. SVG can easily be rendered, created, and edited in several commercial and open source software packages. SVG files are XML. That means the text strings are easily identified, extracted, and transformed. So it basically works like this. It's similar to the workflow you've seen before. We have a source language image created in standard tools that's saved as SVG. We transform that into a single XLIFF file via XSLT. This single XLIFF file contains all of the strings for translation. The localization service provider translates the XLIFF file. Then it becomes a bilingual file. We transform that back into SVG, and we have translated images. So let's take a look. I've got this image that has text. This is how it looks in SVG. The text is readily identifiable and extractable. We transform that into our familiar XLIFF. We leverage the TMX file that has these previously translated strings, and we create a translated XLIFF file now that has the German translations in the target elements. We transform that back into XLIFF, and we have a translated SVG file now that has the German terms instead of the English terms. Okay, so another advantage is that we group all of these all of the SVG XLIFF file elements into a single XLIFF file, and then we can transform in batch, translate in batch. Tremendous time saver. Okay, so that is our video for today. As I said before, this is really important that we are able to apply what we learn to practical situations, and hopefully you've gotten a flavor for how that works. As always, I'm very happy to answer any questions you have or to give you more in-depth demonstrations. Just let me know. Have a great day.